Hi, I'm Steve from ITAD. I'm joined today by Filip, who works in our test lab. Hi, Filip.
Hi, Steve.
We're talking about a new approval that you're going to see coming out from us, which is a security claims test. Now, what's new about it? We have tested companies against this certification before, but what's different about this is that it's a data sanitization certification, and you'll be wondering why we've used our security claims test certification and not our product claims test certification, and that's why this video is being released to try and help explain why we've done that. Now, to put some context into place, as most of you know, we've been testing products for data sanitization solutions for over 10 years now, and we have product claims test, product assurance. And typically our test method is quite robust on both of those types of certification. Now, we were approached by the Goldie Group last year to try and take on a new type of technology, which was earpods and a smart ring. Now, we tested smartwatches. We've clearly tested lots of normal technologies as well. And of course, being a good salesperson, I said, yeah, of course we can do that without really understanding what it would take. And so Goldie delivered their G-Class product to us in August of last year. And since then, we've certified them for smartwatches and smartphones, which is our normal process. But we've taken a little bit longer, and it's just reached the end of that now, to certify them on the smart ring and on ear pods. And I'm going to explain why that took so long and why it's a security claims test. Now, with wearable technology, what we've seen is that depending on the type of technology, there's normally a interface to the device itself. So for example, in a smartwatch, where's mine? My smartwatch here, there's a port that we can use and start to communicate directly with the watch itself. But what we found with the smart ring and what we found with the earpod was that they needed to be paired with a phone. You couldn't communicate directly with the device itself. And so when we started our test process, we had to treat them as one. And that caused us a problem because effectively you would be recertifying the phone part of the relationship rather than just the ring, because they were operating as one. And for that reason, the chaps in the lab turned around to me and said, Steve, our normal test method isn't going to work. And that's where Filip came into it, because Filip is our AI expert and our cyber expert here at DISA. And so Filip, back in whatever it was, August last year, I said, can you write a test method for me to be able to verify that data sanitization on a smart ring would work? And that was the task I gave you back then. Maybe you can just explain, as we introduce this new certification to everybody, what challenges you had when you were thrown the curveball from me last year.
Yes, of course. Like you said before, the ring has no physical port, and we cannot access like a smartwatch. Also, the main challenge was getting access to the data sent between the ring and the phone. Because if we want to test this, we need to firstly to connect the ring to the phone and then to proceed with the testing. That was the challenge.
And so, because it was that relationship where they're paired, we needed to break that relationship and effectively try and get between the natural relationship between the phone and the device itself. I know we talked at the very beginning, you've created a man-in-the-middle attack. For those who work in cybersecurity, they'll understand what that means. But for those who don't, what type of attack were you able to create? Just describe the mechanism that you undertook to compromise that relationship.
Yes, the solution was to try carefully to analyze the communication between the ring and the phone, because of the that communication is a PLE communication, that is basically Bluetooth Low Energy communication. We need to set up to create a pre-configured setup with the machine, the dongle, that is USB dongle, the USB Bluetooth Low Energy dongle, and the phone. When we create that setup, we start listening the communication between the phone, like a host, and the ringer, like a peripheral. That was the first part, is to create the environment for that. Second step is to opt for the reverse engineering process, so we can proceed with the gut enumeration. We can explain gut like some sort of communication interface or data map, and that could be our bridge. When you mentioned the smartwatches, we used to forensic the smartwatches, we used the ADB. That is a bridge between the host and the smartwatch. Here we will use the gut enumeration instead of ADB because the ring doesn't have a port.
So what we were trying to do, I'm guessing then, is inspect the communication between the two. Is that correct?
Yes. To see what is the type of communication and which protocol they are using.
And so from a sanitization perspective, you needed to create an environment where, first of all, you could inspect. So normally we would inspect the media itself, but we were unable to do that because we couldn't connect directly to the device, to the smart ring. And so you started moving slightly outside of the device, and you started looking at the communication between, I call it the host, the phone, and the ring itself. Let's roll this into what we were employed to do in terms of verifying sanitization, because I understand what we've managed to achieve. So we put, in normal test process, we put control data onto the ring. I do believe I saw you wearing it on your little finger walking around the office at one point, just to make sure that we actually had some real user data, and we could see that on the phone because it had been paired with the phone. Did our normal process of imaging to make sure we have a data frame that we can actually see. And then you executed the G-class solution onto the ring. Now, I need to stress that it was a process applied to the ring. It wasn't a process applied directly to the handset. Is that correct?
The process applied between the ring and the phone. I mentioned gut communication, basically. That is a generic attribute. And we use that like a primary method to navigate through the internal structure of the device. In this case, that is a ring. And we treat that services like a logical partition of memory. That was the point of this test. Also, when we analyze the gut features, we successfully isolate specific UIDs. That is a universal unique identifier. Basically, in this situation, that could be a sensor. When we speak about the ring, that is basically the heart rate sensor. And the most important and difficult thing here was to basically sit on that sensor live and measure and track the operations that heart rate is doing.
Fantastic. And I think just to bring it down to the purpose of the approval, and again to make it relevant to the audience today, I think Adesi's got lots of different things to our portfolio, as you know, and we're working in AI assurance now. We're working into more cyber-led types of assurance schemes, as well as ITAD. So data sanitization is still a core part of our business. But this technique, which we were able to compromise the communication and therefore monitor or reveal what was going on between the host and the target, which is a ring in this instance. In terms of the assurance of sanitization, so we put data to it, we used G-class on it, GCAS I should say on it. We were able to monitor the before and after scenario, we were able to monitor exactly what data and traffic was moving from one to another. The objective, of course, is there any user data compromised? Now, how confident are you after the testing that you carried out on the ring and the EarPod that no user data could be recovered?
Yes, from the security perspective and from the forensic perspective, we proved basically that after we perform the wipe process, the next measurement will start clean and the ring will not share or upload any historical data in the database of the phone. And we can easily see that there is no asphalt database on the phone after we wipe the ring.
Fantastic. And I think I think for the purpose today, without going into too much more detail, I think that just to explain why the difference again, product claims test is our traditional method of verifying sanitization, where there's a ability to separate the host, whether that's a laptop, desktop, and the storage media. Even smartwatches fall into that category. This one, because there's symbiotic relationship between the device and the host, meant that we had to separate them artificially and create that man-in-the-middle attack and monitor communications, which I think is a fantastic solution that you've created for us, Filip. And kudos to you and to David as well, and to Phil, supporting in the background for trying to take this on and being able to prove that the Goldie Group solution does protect data by sanitizing the ring in an appropriate way. And that's exactly why we've released it under the device or the security claims test solution. So I'm going to say thank you very much, Filip. Great work. Kudos to you.
Thank you.
If you want to find out more about some of the work that Filip gets up to, please follow our YouTube channel. There's going to be some more things coming out about the world of AI and AI assurance shortly. So thank you for watching today.
Thank you.